Hey pre-calcers, I wanted to give you a quick set of examples for the practice on sine and cosine functions, and we're graphing these. The first few don't ask you to necessarily graph these functions, but we still have to find some important information that we would need, ideally, if we were to graph them. Those two things being the amplitude and the period. So recall that the amplitude measures how far away from the center line the highest point is and the lowest point. So in this case, this amplitude would be like 1 unit. The same way, this distance from the center line here to here is just 1 unit. And this is always thrown towards the front of the equation, so recall that when we first got a glimpse of these equations, we dealt with terms like this, where the a term was in front of the sine or cosine function. Then we had our b term, which was next to x. And then we had occasionally a horizontal shift and then a vertical shift. We didn't see too much of the horizontal shift or the vertical shift, and I don't think those are really covered here, so that's why I use this practice. All right, let's get to it. We should also recall that the period can be found if we take 2 pi over our b term and then simplify that. So this first one is y equals sine 4x. There's no term in front here, so we can assume that our amplitude is just 1. And if we're going for our period, our b term here is 4. So if we take 2 pi over 4, can we simplify this? We sure can. We could rewrite this as 2 times pi over 2 times 2. So rewriting 4, we can cancel our 2's, and our new period is pi over 2. Pretty simple. We'll do one that's a bit more complicated now with cosine, where in this case, although the a term is negative, whenever we measure amplitude, we're always taking absolute value of our a term. So if we take the absolute value of negative 4, this is just positive 4, which is our amplitude. Simple. Taking this further, our b term here is 5. So if we take that period, 2 pi over 5, we can't simplify this fraction anymore, so that's it. Done. Let's see what else is on this worksheet. We have to find the amplitude and the period for each of these graphs. I will do my best to cover definitely a cosine version and a sine version. We'll start on 11. So when I look at this, there are a few things that I look at first, and I kind of go in this order that's mentioned down here, where the first thing I would want to notice is the amplitude. Since it looks as if the very middle of our cycles revolves around where this blue line is, we can just measure this amplitude pretty easily from here to here. So what's that amplitude going to be? You should be saying 4. So that's simple. If we're taking a look at our period, this is the distance for one full cycle to complete. So we see here we're starting at a high point, and here we're going to another high point. So this distance, marked out in red, is from 0 to 2 pi. So our period in this case is just 2 pi. Okay, so we're looking for an amplitude of 4. So that should definitely be in the front. And it's not flipped over. Like occasionally if the a term is negative, the whole graph will kind of be flipped over the x-axis, but in this case that's not the case. And this is a normal 2 pi period. And since we're starting way high up, recall we think of this like a roller coaster. We swing down and then swing back up. So this is a cosine function for sure. And there we don't have to modify anything inside parentheses because it's just a normal 2 pi period there. Nothing too crazy on that one. Let's see if we can get this sine one. So I know that this is sine specifically because it's starting right at 0. So we definitely want to make sure that this is a sine function. Our amplitude here is from 0 to 2, so it's definitely an amplitude of 2. It takes how long to complete a full period? Well, we see that this goes up, then swings down, and then ends up back where it starts at 0, and that goes over 4 pi. Okay, so when we're trying to create the equation, this can be a little tricky, but recall that our period is achieved by taking 2 pi over our b term, and in this case, if we replace our period with the 4 pi, so 4 pi equals 2 pi over b. Our goal in this case is going to be to solve for b, which is here. So we can multiply both sides by b. Here and here, this gets b times 4 pi equals 2 pi. And then how can we isolate b? If we just divide by 4 pi. Easy. All right, so 4 pi cancels. Our pi terms can cancel here. 2 over 4 can be simplified to 1/2. So that's our b term. So if we rewrite this, we can have y equals 2 for our amplitude, sine. Then we need 1/2 in front of x. And that's it. So a little bit of a different conversion if we're solving for the b term, given just the graph. Notice how we did that. Down here, we're graphing out some of these. I don't think these are too tricky. Let's see if we can find one that has a little bit more to it. We'll start simple. We'll do a mix of a sine and a cosine. All right. So this amplitude I'm looking at is definitely going to be 3. If we get our period, 2 pi over this 2. 2's can cancel. This leaves us with a period of just pi. So this is saying that we will have a full cycle completed if we start at 0 and then end up at pi. So that means that in between 0 and pi, we need to have that full cycle that's going up to 3, crushing through the 0 on the x-axis, going all the way down here to -3, and then going back up. And we can keep this formation going. So after pi, it's going to go up to 5 pi over 4. It's going to cruise back down to 3 pi over 2. Cruise even farther down for 7 pi over 4. And keep this going. So you can start to see a pattern when you map these out where after every 2, you're just going to mark up on the x-axis. So let's mark here and here and here and here. For the other markings, we kind of have to be careful here, but this is spaced out after every 4. So count it 1, 2, 3, 4. So you can do the same thing here. 1, 2, 3, 4. Mark that. Reverse it for up here. Mark down here. Mark up here. And then just draw this out. Do as best as you can to make this a wave. So going up, cruising down. Oh, that wasn't great. And these take time, so Don't be afraid to use graph paper. That's helpful. And you can draw the arrow to keep them going like that. So that's the sine. Let's see if we can get a cosine one. I'm sick of amplitudes of 3. Let's find one that's different. All right, so this is going to be simple to map out. That's actually too similar to the other one. Let's see if we can get one. Well, let's just keep it simple. 2 cosine of x. Cool. So our amplitude in this case is 2 because that's the number in front. Our our period is not going to change because our b term is just 1. So our period in this case is just 2 pi over 1, which is just 2 pi. So after 2 pi, this is going to complete one full cycle. So after per pi, it's going to go back down. Let's mark up this 2, this starting 0. This x-axis is kind of wonky. Nope, blooper, because this is supposed to be cosine of x. So let's mark up this is 2, and we eventually want to end up here. Halfway in between, we're going to get to this negative 2. Yeah. And so we just mark up how this can go. So notice this is a normal cycle of 2 pi. So this one isn't too crazy to map out. Do your best to make this a smooth line. So swing this up, then down. Do the same over here. Where I see students trip up is that they'll do just such a sharp line to the next point, and that it looks kind of ridiculous because recall that these should kind of wave in like a wave, like have this kind of smooth in like that.